Welcome to Study Loop.
This is the answer to Chapter 21, problem number 73 from the Smith Organic Chemistry textbook. And this problem gives us two reactions and asks us to draw a stepwise mechanism for each reaction. Okay, so for A here, the first step in this hydrolysis is going to be protonation here. So this oxygen will grab an acidic proton. Okay, so this oxygen is now protonated. So it has a positive charge and only one lone pair. And so hopefully we know by now this is going to make it a much more suitable leaving group. And so that is what's going to happen. The carbon-oxygen bond will break, and those electrons will go to the oxygen. And so now we will have this structure with a carbocation here where the oxygen was formerly bonded. And so this is going to provide a space for a molecule of water to attack. So water can act as a nucleophile and attack that carbocation. And so that is what will happen here. Okay, and then that water that added can be deprotonated by another equivalent of water. Okay, and now the oxygen that is part of the ring can be protonated. So another molecule of acid, so H3O plus. You know what? I forgot to include the plus sign there on the first one, so there that is. So another molecule of H3O plus can protonate this oxygen. So this oxygen now has a positive charge and only one lone pair. And so the next step is going to be simultaneously one of the lone pairs on this oxygen will add in here to make a double bond. And this carbon-oxygen bond here will break. And so that is going to open our ring. And so we will have 1, 2, 3, 4. This structure and basically the last thing that needs to happen is deprotonation of that aldehyde. and that can be accomplished by another molecule of water to give us our final product. Okay, so that's part A. So let's take a look at part B. So the first thing that needs to happen in part B is our benzaldehyde is going to get protonated, and this needs to happen first because it's going to make the benzaldehyde much more susceptible to nucleophilic attack. Okay, so we have our protonated benzaldehyde here. Let me move this back up here. Okay. And so the next thing that's going to happen is going to be an attack by one of these oxygens. So that's going to happen like this. These electrons will move like this. And so after that, we'll be right here. Oops. Okay, so there's now only one lone pair and a positive charge on this oxygen. The other oxygens still have two lone pairs. And so the next thing that needs to happen here is going to be deprotonation of that oxygen to relieve that charge. So water can do that. Okay. All right. And so now we need to protonate this other oxygen. And so we can use another H3O plus to accomplish that. And once again, I forgot the positive charge on this first oxygen. So there that is. And let me not forget it this time. So there we go. This oxygen will get protonated like this to get us to this molecule. And so now this is a good leaving group is water. And so that's what will happen. This will take off as water. And the result of that is going to be the formation of a carbocation at that carbon. So we have a carbocation here now. And so this oxygen is now well positioned to attack that carbocation. So that's what's going to happen. And now we've formed our product molecule, essentially. And the last thing that we need to do is just deprotonate it. And so that is going to be the last thing that happens. And once again, we will use an equivalent of water to come along and grab this proton. And that is going to get us to our final product. Okay, and that's the answer to part B. So the mechanism for part B right here, the mechanism for part A here on this first page, and that's the answer to chapter 21, problem number 73.